Hey, on this video, I want to work the first 4 problems from paper 1 of May 2014. So pretty recent. These first few problems are not too tough. They usually start off pretty easy. They get harder towards the end of the paper. So let's take a look at problem number 1. It says when the polynomial and given a polynomial is divided by x minus 2, the remainder is 2. When it's divided by x plus 1, it's 5. Find the values of a and b. Well, just remember the remainder theorem, which says if you divide by x minus k, that's the same as evaluating p of k. Whatever that gives you is the remainder. So, for example, if p of k equals 0, then that means that k is a root of the polynomial. So what we're going to do here is use that fact, and we know that x minus 2 is the divisor, and the remainder is 2, so I'm going to substitute 2 in for x. So 3 times 2 cubed plus a times 2 plus b, the remainder is going to be 2. Okay, so we can clean that up. That's 3 times 8 is 24 plus 2a plus b. And so I'm going to have 2a plus b equals negative 22. Now I got 2 variables. I'm trying to find a and b, so I need another equation. That comes from the second part of the question. When divided by x plus 1, the remainder is 5. So that means p of negative 1, remember opposite sign there, will give us a remainder of 5. So I'm going to substitute negative 1 into that polynomial. So 3 times negative 1 cubed minus a plus b equals the remainder of 5. So what do we got there? We got negative 3 minus a plus b equals 5. Negative a plus b equals 8. So there's our 2 equations. And solving for a and b, I think I'll just move that second equation over under the first one and then carefully subtract. Don't want to mess up the signs. So subtracting 2a subtracting negative a is 3a. And b minus b, goodbye. Negative 22 subtract a is negative 30. Therefore, a equals negative 10. And subbing that back in somewhere, well, I'll just take it over here. Negative 10, that becomes positive 10 plus b equals 8. Therefore, b equals negative 2. Yay, it's done. 5 marks. Easy 5 marks. All right, so much for problem number 1. Problem number 2, a 4-mark question. It really doesn't have much to it. It's kind of a guess and check thing. You have 4 numbers. So 1, 2, 3, 4, and it tells you their mean is 13. So if the mean is 13, that means if we add those 4 numbers and divide by 4, we're going to get 13. The median is 14, so the middle number is 14. Well, since there's only 2 numbers, the median is going to be the average of those 2. So the average of those 2 is going to give us 14. And the mode is 15. Well, the mode means the number that's up there the most is 15, so that makes you kind of think, well, there must be 2 15s. Let's try that. As I said, it's kind of guessing and checking. Now, if that's the scenario, then if you have a median of 14, the 2 in the middle have to average to 14. So if that one is 15, then this one would be 13. And since the mean is 13, that means the sum of those numbers is going to have to be 52, because the sum divided by the number of numbers, which is 4, has to equal 13. Multiply both sides by 4. The sum is 52. So if we add the 3 that we have there, we have 15, 15, and 13, which is 43. That means that would have to be 9. Now, let's check everything. Is the median 14? Well, yeah, we created that. Is the mode 15? Obviously, 2 15s. Is their mean 13? Add it up. 22 and 30 is 52 divided by 4 is 13. Yay, everything checks. And we're done. Guess and check. So the 4 numbers are 9, 13, 15, and 15. Number 2, done. Problem number 3, another pretty easy 5-mark question. You want to try to get all these easy ones as much as possible, because you know they're going to get tougher towards the end. But this one's fairly easy if you know your log properties. we're trying to find the value of a, and a is equal to that product of some logs. Now if you look at it, you can see, well, the bases start at 2, 3, 4, up to 31, so the bases are increasing by 1. And then the log of 3, log of 4, log of 5, they start at 3 and increase by 1 up to 32. So how can, without a calculator, of course, this is paper 1, how can we find the value of a? Well, what you want to use is the change of base formula, which says the log of 3 base 2 is the same as log 3 divided by log 2. That's just a basic log fact. So let's write it like that, and then the next one would be log 4 divided by log 3, etc. Let's just write a few of those and see what happens. I'm just going to throw another one in there that they don't have, but the pattern continues. Log of 6 over log 5, and we know the last one is log 32 divided by log 31, so let's put the next to last one in there also, and then we'll put some dots in the middle. So log would be 31 over 30 log. Okay, what's going to happen? Well, start canceling like crazy. The log 3 cancels, the 4 cancels, the 5 cancels, and you can see the top log is always going to cancel until you hit that last one. That one's going to have to remain because that top log cancels with the next following term. Okay, let's look at the denominators. Or what else cancels here? Well, it looks like, well, what happens is everything cancels except for the log 32, and then the log 31 will cancel, and the 30 will cancel with the prior one. So all you're going to be left with is log 2 on the bottom from the very first term, and log 32 from the last one. And there's our answer, but I guess we can clean that up a little bit. Using the change of base formula again, log 32 divided by log of 2 is the log of 32 base 2. Well, what power of 2 equals 32? And that is 5. And there's the answer. 5 marks. Problem 4 involves the sum of roots and product of roots. Now, you really have to get this down because they've tended to use this question a lot in most recent tests. So we have a polynomial equation, highest power is 3, equal to a. It says it has 3 roots, r1, r2, and r3, and that the sum of the roots plus the product of the roots equals 0. All right, so you have to know your facts about the sum of the roots and the product of the roots of a polynomial. Well, before we go, let's rewrite this thing. I'm just going to bring that a over because it's technically part of the constant. So it's 2 minus a. That's the constant of this equation. Now, the sum of the roots, and this is always true, and you need to know this, the sum of the roots is negative b over a. Of course, a, b, c, etc. are the coefficients of the terms when they're in order. So the sum of the roots is negative 48 over 5. So in this case, that's r1 plus r2 plus r3. Now the product of the roots, that gets sometimes a little confusing because the product is the constant over a. But it depends on the number of terms. If the number of terms is odd, then it's a positive constant over a. If the number of terms is even, then it's a negative constant over a. So what I do, I remember it this way. It's negative 1 to the n minus 1, where n represents the number of terms. So in other words, in this case, we have 1, 2, 3, 4 terms. So it's negative 1 to the 4 minus 1, or 3. That means it's going to be the negative constant over a. Okay, a being the coefficient of the x cubed term. So, well, in this case, the negative constant would be the negative of 2 minus a over a, the coefficient of the x cubed term, 5. So this is the product of the roots. Well, the product of the roots is r1 times r2 times r3. So let me find some room where I can write this. Let me go back up here. R1, R2, R3 equals, I'll just go ahead and distribute that negative. A minus 2, I guess, yeah, over 5. That's the product of the roots. So let's take this equation they gave us and just write it out. R1 plus R2 plus R3, that's the sum of the roots, and we already know that that's 48/5 negative. Plus R1 times R2 times R3, well, we just figured out that that is A minus 2 over 5. And that is going to equal 0. Well, this is nice. Multiply through by 5, and we get negative 48 plus A minus 2 equals 0. Negative 50 plus A minus 2, whoops, I combined negative 48 and negative 2. Negative 50 plus A equals 0, therefore A is 50. And we're done. But, yeah, you got to remember this. That's the trickiest part. How to find the product of the roots, constant over A, and it depends on the number of terms, whether it's negative or positive. If you ever get confused or forget that, just think of a simple example, like maybe x minus 2, x minus 3. The roots of that equation are 2 and 3, and their product is 6. Now when you FOIL that out, you get x squared minus 5x plus 6 equals 0. So the sum of the roots, the sum of 2 and 3 is 5, so it's negative b over a. And the product of the roots is 6, so in this case, it's the constant, the positive constant over a. So we have 3 terms, an odd number of terms gives us a positive. Whereas in this problem, we had 1, 2, 3, 4 terms, which gave us a negative constant. So it's kind of backwards. You think even negative or even positive usually, but in this case, an even number of terms gives us a negative constant over A as the product. So a little confusing. You just want to get that straight in your head, or just always think of this simple example if you forget.